normally go into my presentation.
Please.
So, dear participants, as you have seen, actually, I am from Department of Environmental Sciences, Andhra University, and today's program or today's discussion is probably I would like to discuss one of the very important environmental issue that the humanity is normally facing, that is global warming. So today we would like to have some discussion on this particular very important environmental issue that is normally confronting the humanity right now actually. So before I normally launch myself into this particular discussion, probably I would like to have a very small introduction actually before going into the actuals of this particular global warming. So I think probably since the course has started on 5th, 7th of this particular month, I am sure that you must have good amount of discussions on different aspects of this particular environment. But still then I would like to normally go for a very brief introduction of this particular lecture actually. So when you normally look into this particular the term environment. So the general definition that we normally offer for this particular environment is surroundings. That's how people normally look at this particular term environment. And when you are normally looking at surroundings, actually, automatically it comes to our mind that two components normally comes to our mind immediately. That is biotic component and abiotic component. Of course, biotic component, maybe majority of you may be coming from life sciences. You will be normally knowing that life systems probably. Abiotic component probably, as we normally see, probably air, water and soil, or you can also normally call them atmosphere, hydrosphere and lithosphere. So these are the basic things that we normally see from the term environment. And the one that I am normally going to discuss today, or maybe it is more related to atmosphere, but its impact is normally felt on hydrosphere, lithosphere and biosphere as such actually. So that's why probably though the issue is normally related to the lower atmosphere or atmosphere actually, but the impacts will be normally felt on the biosphere. Of course, once we are normally talking of biosphere, automatically it is lithosphere and hydrosphere. So when we normally look into this particular atmosphere or air, actually, it consists of 5 layers, maybe troposphere, stratosphere, mesosphere, ionosphere, and exosphere. These are the 5 layers that we normally see in the broad single layer of the broad layer of atmosphere. Actually. But this particular 5 layers are normally divided on the basis of temperature. So it is normally the temperature which normally is the yardstick for making this particular big atmosphere into small layers like troposphere, stratosphere, mesosphere, thermosphere or ionosphere and exosphere. So this is the information which I would like to normally provide before I normally go into this. And here you must have seen in the diagram you must have seen the temperature profile of the atmosphere. So in the troposphere, the temperature normally declines, whereas in stratosphere the temperature increases. And again, mesosphere is a replica of your troposphere, wherein the temperature normally declines actually. And when you normally look at thermosphere, actually it is again a replica of stratosphere, and it normally continues actually. In thermosphere, probably you have 2 spheres actually, ionosphere and exosphere. Ionosphere is also very hot, and the same thing will be continued actually when you normally reach exosphere. So this is some information I would like to normally share before I normally look into this particular today's discussion as far as global warming is concerned. So when we normally look at this particular global warming, I would like to normally look at the present scenario. So when you normally look at the troposphere or lower atmosphere, probably you normally see certain things. Actually, certain things are normally seen in this particular thing actually. So when you normally look at the present scenario, glaciers are melting. So everybody will be normally definitely you are aware that all the glaciers are melting throughout the world actually, and sea levels are also rising. Again, the same thing actually is happening in any part, probably in either it can be Bay of Bengal, or it can be some other sea or some other ocean, doesn't matter actually. The sea levels are rising in general, and cloud forests are dying, and ambient temperatures are increasing actually. Definitely you must have felt actually, if you can just think of 5 years back in your place and today's temperature, if you compare the temperature of 5 years back and today's temperature, probably you will be normally visualizing this actually, that ambient temperature of the lower atmosphere is rising, and of course wildlife is scrambling to keep pace with many changes that are normally taking place. And of course rain patterns are normally changing actually, and many things are normally happening actually. All these things are normally happening as far as the lower atmosphere or troposphere is concerned, and this is the situation that we are normally placed right now as far as the humanity is concerned, whether it is Asia or whether it is Africa or whether it is Latin American countries or whether it is something like Europe, doesn't matter actually. Wherever you normally see, these are the things that we normally see. And same thing, if you can normally look into why this is normally happening right now. Earlier we have not seen this actually. I think even our predecessors, they never saw this type of things actually. But why this is normally happening right now? This is the question that is normally raised by each and every society actually. That means different or each and every group, rather I can say actually. For this, probably I would like to just look into something that happened earlier, and maybe I would like to look into that particular something like some 200 years or 250 years, probably what happened, and probably I would like to get the connection from that particular area. So if you normally look into past, probably majority of the time actually, so most of the time man was human was the source of energy. So we were normally employing our hand processes for making many products actually, for manufacturing. If you normally look at the manufacturing earlier actually, most of the time it was the humanity which used to normally use its energy, and most of the time hand processes were employed for manufacturing processes actually. So this was the earlier time, maybe before 1760, maybe around 1740, and before 1740 or 1760, probably most of the time hand processes were employed, and there was mostly you have, that means hand processes were employed in the sense man was the main attraction. So you have limited amount of energy actually. That I want to drive at you actually. That means the energy at that particular point of time was normally was used for limited energy was used for manufacturing processes. But in 1970 to maybe in between 70 and 1840, especially in Europe, again especially in Great Britain actually, if you take political compulsions, development in science and technology, population growth, and of course other things are also there actually. Population growth has necessitated to produce more. So there were some compulsions actually, either they mostly political compulsions. Maybe at that time again we started looking at science and technology. There was growth in science and technology, and of course as a result of this there was population growth actually. So all these things have necessitated actually to go for more production. So you have to produce, because once there are more population, automatically have to produce more. So this is, there were some compulsions actually. So this led to the transition of hand production methods to machine, which was termed as Industrial Revolution. So in between 1760 and 1840 probably, man was replaced by machine. So that was the classical thing that has happened actually. If you look at the period 1760 and 1840 probably, man was slowly and steadily replaced by a machine actually. So this is what exactly we call Industrial Revolution. So these people called it as Industrial Revolution. So this Industrial Revolution marks a major turning point in history. Almost every aspect was affected actually. That means rather either mostly positively actually, this Industrial Revolution probably it affected each and every aspect of the daily life actually. Maybe we started producing more. So that was first thing actually, because machine was normally employed, so you can normally produce more actually. Once you are normally producing more, in the sense automatically you are consuming more. So you started consuming more and more resources. So this is also, once you started consuming more and more resources, then you started producing more and more products actually. Then population again, because population started increasing actually. So then probably many things have happened, and in this particular thing probably I can very confidently say that we started using more resources and we started producing more products. This is the thing that has happened. And in between probably as an ancillary, we have also started producing more and more waste products. We have started producing more and more waste products actually. So this is what exactly has happened as far as this particular Industrial Revolution is concerned. So the Industrial Revolution assured a classical change in the resource consumption versus waste production. So once you are consuming more, automatically you are producing more, and same is the case with waste also. You started producing more. We started producing more and more waste products. And this generation of these waste products, they are both solid, liquid and gaseous. So all the three we started producing more actually. So consumption was there, production was there, and with the products actually we also started producing more and more waste materials. Waste materials may be solid, may be liquid and gaseous ones. So if you normally analyze this particular scenario actually, in this perpetual advancing and developing era, there is no doubt that world is changing. So definitely world is changing actually. So however, the question is whether it changed for the better or the worse. So when you normally look at this particular change probably, definitely you may have to think whether we are normally going on a positive note or a negative note. These are the things that people are normally, people have questions actually on this. But if you want to answer this particular question actually, probably you may have to take two scenarios actually. The first scenario is actually, if you are normally looking from the global economy point. So the first scenario, if you normally look at the global economy point actually, definitely we are normally advancing. So definitely there is progress, because we started producing more and more products actually, and as a result of this probably the world economy has started, or the global economy has started moving positively actually. So from the global economy point of view, definitely it is a positive thing. But when you normally look at the global climate or ecology wise, if you take actually, definitely we are striding towards displacement. So you have to look at the two scenarios actually. That means once if you normally look at the economy point of view, definitely we are normally progressing. This Industrial Revolution has brought economic progress, definitely. That is, nobody can deny it actually. But at the same time, if you normally look at the ecology point of view actually, definitely we are normally going for displacement. That means maybe there are changes started actually as far as this particular ecology is concerned, actually, world ecology is concerned. So clearly there is a strong relation between the industrial revolution and climate change, and the relationship between them ought to be analyzed if we want to live in a better world. So when you normally look at the small discussion we have right now, actually, this clearly indicates actually that this particular industrial revolution has definitely brought some change, and it also normally provides good information regarding the relation between the industrial revolution and the ecology of the universe, actually. So these two probably we have to keep in mind, and if we normally discuss this, probably then we can normally think, if we want to be at least in the present state, probably we should normally understand what exactly is happening, and basing on that, probably you may normally have strategies which can normally allow us to keep at least like this. So that's why probably we have to have some sort of discussion on this particular global warming, or the relation between the industrial revolution and the present day environment, actually. And probably then we can normally take which particular view we are going to take to keep at least the universe in its present state. So the concept of global warming can be better understood by considering the energy balance of Earth's surface, whose temperature is determined by a balance of incoming and outgoing short wave and long wave radiation. So once you normally, if you want to normally study this particular global warming, then you should have a very clear understanding of the energy of the universe. So if you normally look at the energy of the universe, probably two things normally comes to us. One is the incoming radiation, and the second one is probably the outgoing radiation. So if you can normally understand these two very clearly, probably you will be normally knowing why this global warming is normally taking place, and what are the measures that we can normally think of actually to reduce this particular global warming. So you have to have a very fine idea of this particular incoming radiation and outgoing radiation, and these will normally provide us ample information why this global warming is taking place. And once you normally know that these are the reasons, actually, then you can think of actually what are the strategies that you can think of to reduce or to mitigate this particular global warming. So that's why probably energy balance of the universe is at most important, actually. We try to understand what exactly is happening. So global warming mainly refers to the steady increase in the temperature of the lower atmosphere. This is due to the trapping of heat by greenhouse gases, and hence the accumulating heat in the lower atmosphere. These human-produced greenhouse gases include carbon dioxide, methane as well. So when you normally look at global warming, the very meaning of this particular global warming in the sense is increase in temperature. So the globe is slowly and steadily increasing its temperature, actually. So this is what exactly in its the meaning of this particular global warming. Why this is happening? So is global warming a recent phenomena? Why this is normally, people are normally looking at this particular global warming so serious? So let us normally try to find some answers for this. So global warming is not a new phenomenon. First of all, let me make it very clear, actually, that global warming is not a new phenomenon. It has been there, actually, and it will continue to be there, actually. But only thing is, actually, how we are going to see this particular pattern, probably that will be normally depend. That is mostly our activities, or rather anthropogenic activities will normally decide how we want to see this particular global warming in future. So when you normally look at this particular global warming or greenhouse effect, As I said, actually, this is the consistent and constant increase in the temperature of the troposphere or lower atmosphere. So that's how people normally consider this particular phrase. Global warming in the sense warming of the globe. So how it is happening? It is consistent and constant increase is normally taking place as far as the lower atmosphere is concerned or troposphere is concerned. So in troposphere, the temperature is slowly and steadily increasing, and that particular process, what we normally call it as global warming or greenhouse effect. Greenhouse effect in the sense the same thing you normally see in a greenhouse. In a greenhouse is normally used actually for rearing certain species actually, and which normally requires certain amount of high temperature. In that particular case, actually, probably we are using this particular greenhouses actually. And the process that is normally taking place in a greenhouse is normally seen in the entire globe. That's why it is normally global warming or greenhouse effect. It's called global warming or greenhouse effect. So if you normally look at the reasons, maybe increase in the concentrations of greenhouse gases like carbon dioxide, methane, chlorofluorocarbons, oxides of nitrogen, etc. It's the concentrations of these particular gases are normally increasing due to increased use of conventional energy resources. So this is one thing probably you may have to keep in your mind actually, that today's energy requirement of the universe, if you normally look into probably, and the energy requirement of the universe is mostly met by the fossil fuels or the conventional energy resources or carbon-based resources actually. So maybe I think around 70% or 70 to 75% of our energy requirements are normally met by either coal or oil or natural gas actually. So these are the three things actually which are normally very much used for the generation of energy. And when you are normally using these particular resources for generating energy, automatically you will be normally producing a lot of carbon dioxide and of course a lot of oxides of nitrogen. These two are a must, because the type of combustion that we are normally practicing right now is aerial, or using the air. We are normally going for combustion actually. We are not using oxygen actually, we are using only air. So air normally contains 20% of, around 20% is oxygen, and maybe nearly 79% is nitrogen actually. So that's why still, since you are normally using air as an oxidant, so automatically apart from carbon dioxide, you will be normally producing large quantities of oxides of nitrogen in your combustion activity. So that's why as long as you use this particular conventional energy resources for generating energy, you have no other goal except to generate large quantities of carbon dioxide and large quantities of oxides of nitrogen. So this is a must. So if you replace air with pure oxygen actually, then automatically you can normally reduce all these things, but it is very way away, because the economics does not allow us to go for pure oxygen, and we will be normally left with only air actually. So these are the things that are normally happening as far as the energy front is concerned, and as a result of this, we are normally producing a lot of carbon dioxide and a lot of oxides of nitrogen. These greenhouse gases absorb the outgoing infrared radiation, and in the absence of this particular infrared radiation, so if you normally look at these particular gaseous components which I have mentioned, carbon dioxide, methane, chlorofluorocarbons, oxides of nitrogen, these have a very specific property. That property is actually, they normally try to absorb the long wavelength radiations. That means lower wavelength, lower energy radiation or long wavelength radiation, they normally absorb. They have that particular ability to absorb this particular higher wavelength radiation or lower energy radiation actually. So in this since they have this particular specific property, probably these greenhouse gases, they try to normally absorb the outgoing infrared radiation. So the infrared radiation which is supposed to leave this particular lower atmosphere, it is normal, they absorbed by this particular gaseous molecules, and as a result of this, the infrared radiation is normally retained by the gaseous molecules that are normally present in the lower atmosphere. So since energy is absorbed, so automatically the temperature normally increases. So once the energy is absorbed within the lower atmosphere or troposphere, automatically the temperature of this particular lower atmosphere is also increased actually. That is what exactly is happening as far as the troposphere is concerned. So if the presence of this particular CO2, methane, CFCs, oxides of nitrogen and other greenhouse gases, if they are not present in great quantities as far as the troposphere is concerned, probably then we may not see this particular so-called global warming. But because this lower atmosphere is normally stationing a lot of greenhouse gases like carbon dioxide, methane, CFCs, oxides of nitrogen, CFC, SF6. So many things are normally seen actually, and all these molecules, they have the specific property of absorbing this particular infrared radiation, and once radiation is normally absorbed, and automatically it try to increase the temperature of this particular region, and as a result of this, probably we are normally seeing the growth in or increase in temperature actually. So that is what exactly, in brief, if we want to normally say why global warming is normally taking place. So let me normally look into the aspects probably relating to the persons who are normally responsible. So the greenhouse effect was discovered by Joseph Fourier in 1824 and reliably experimented by Tyndall in 1858 and first reported quantitatively by Arrhenius in 1896. So these are the things, these are the people actually who are the pioneers actually. In fact, it was discovered by Fourier, Joseph Fourier actually in the year 1824 and maybe reliably experimented by John Tyndall in 1858 and reported quantitatively by Arrhenius in 1896. These are the people actually who are normally responsible, and if at all we are normally studying this particular greenhouse effect, actually probably all the credit normally goes to these three gentlemen actually. So if you as I said, I made one particular comment actually that greenhouse global warming is not today's business actually, it is happening. It was there actually. That means global warming is not the phenomena that we are normally seeing today. So it was there actually, it was there earlier also. So how it was there? Earth's natural, let us normally look at the Earth's natural greenhouse effect. So that means nature has actually, or Earth has some natural greenhouse effect was there actually. But in recent time, for various reasons, probably it has enhanced actually. So the financer of the Earth is definitely sun. So what all the energy that we normally receive today is just because of sun. Sun is the financer of the Earth's energy, and we are normally receiving this particular energy in the form of radiation. And of course, when you normally look into radiation, probably this energy normally comes in the form of electromagnetic radiation, and electromagnetic radiation normally consists of many wavelengths actually. That means you have very short wavelengths which is high energy component, and also very long wavelengths where the energy is very less. So you have a spectrum of wavelengths that are normally embedded as far as this particular embedded in this particular electromagnetic radiation actually. So when you normally look into, when we normally receive this particular energy from sun actually, so the incoming radiation from sun is mostly in the form of visible light. So visible light we normally receive, as far as your troposphere is concerned, it normally receives energy in the form of visible light or in the nearby wavelengths actually. So mostly we normally receive this energy in the form of visible light. And once we normally receive this particular visible light actually, maybe I think roughly around 30% is normally reflected back into space by at least two bright surfaces actually. One is clouds. You normally see a lot of clouds actually. So these clouds, they normally reflect some of this particular incoming radiation. Maybe you have also good amount of ice is available actually. This ice also normally reflects around roughly it's around 30% of the incoming radiation is normally reflected back to the space actually. So that is what exactly is happening. And out of this particular 70%, which is normally reaching the Earth's surface, maybe this is absorbed by the gray body in the sense Earth actually. It is absorbed by the gray body, and once it is normally absorbed, again part is absorbed and rest of the things are normally reflected back. So this is what exactly is happening. So the entire energy component that is received by this particular troposphere, part is normally sent back to the space, maybe by clouds and ice actually. And whatever that is normally coming into the troposphere actually, it is normally absorbed by the gray body, that is Earth, and it normally absorbs some amount of energy, and rest will be normally once again reflected back into the troposphere. So this is what exactly is happening as far as the Earth's energy is concerned, or energy balance if you take. So once this particular energy is reflected back into the troposphere, maybe the rocks, air, and the seas warm up. So this particular energy probably it tries to normally warm up this particular rocks, air, and the sea actually, and they radiate heat energy. So once they warm up actually, they try to normally send some energy from their bodies actually. So this is what exists. So thermal infrared radiation. So that means the incoming radiation is the incoming radiation that we normally see is visible light actually, whereas the outgoing radiation is infrared radiation, because we are normally losing some amount of energy in the form of absorption actually. So as a result of this, the incoming visible radiation will be converted into infrared radiation. So when it is normally going out, it is infrared radiation. From the surface, this energy travels into the atmosphere, where much of it is absorbed by water vapor and long-lived greenhouse gases such as carbon dioxide and methane. So, as I said, actually, once this incoming radiation is converted into infrared radiation, and when it is normally going out, in the absence of this particular gaseous molecules, this infrared radiation will normally leave the troposphere. But because the troposphere normally contains this particular water vapor, carbon dioxide, CFCs, NOx, all these things actually, these have the special ability to absorb this particular infrared radiation. They try to normally absorb this particular energy, and they try to retain this particular energy within the troposphere. So when energy is retained in the troposphere, automatically you have no other go except the increase in temperature. So that's what exactly is happening as far as the troposphere is concerned. So when they absorb the energy radiating from the Earth's surface, greenhouse gas molecule turn into tiny heaters, like the bricks in a fireplace. So if you normally observe in a brick fireplace actually, probably when the energy is normally available, all the bricks, they normally absorb this particular energy, And even once you normally take out this particular energy, these particular bricks will they try to normally radiate this particular energy because they normally contain some energy in it actually. That's why they try to normally dissipate this particular energy into all directions. The same thing is normally happening actually. They radiate in all directions. The energy that radiates back towards Earth heats both the lower atmosphere and the surface, enhancing the heating they get from direct sunlight. So this natural absorption of heat is beneficial for life. In fact, if it is a natural one, that means if there is no human intervention actually, and if it is only propelled by the natural forces, probably it is advantageous to us and to the life on the earth actually. How it is providing advantage to us, let us see. If there were no natural greenhouse effect actually, the Earth's average surface temperature would be a very chilly minus 18 degrees centigrade. That means 0 degrees Fahrenheit. That means temperature will be very, very low actually. But what exactly is happening today is actually because of this particular greenhouse effect, probably we are very comfortable at an average temperature of 15 degrees centigrade. So the Earth's average temperature is 14.5 degrees centigrade to 15 degrees centigrade actually. That is just because of the natural greenhouse global warming that is normally taking place. Because of this particular natural global warming or natural greenhouse effect actually, this is normally happening. So your greenhouse effect is normally benefiting, provided if it is normally happening naturally. So if there is no intervention from the human race actually, then definitely this particular greenhouse effect is beneficial to the life systems that are normally present on the earth, or for the ecology of the earth actually. But what exactly is happening today, let us see. Let us see the enhanced greenhouse effect. Why this particular today's greenhouse effect, if you take actually, it is enhanced greenhouse effect. Since industrial revolutions, humans have been artificially raising the concentrations of greenhouse gases in the atmosphere at an ever-increasing rate. So definitely, because once we have replaced the man with machine, actually, automatically we started consuming more and we started producing more and more waste actually. And as a result of this, we started producing more and more waste gases, or the gases, carbon dioxide, oxides of nitrogen. These things we started producing more and more. So why we are normally producing this more? Probably because of burning of fossil fuels. As I said, actually 70 to 75% of today's energy requirements is normally met by the energy generated from fossil fuels actually. So as a result of this, probably we are producing more carbon dioxide and more oxides of nitrogen. The second thing is actually that we are also cutting down the carbon absorbing forests. That means because the population is increasing, so automatically you may need actually more probably more shelters actually. So for this, probably what we normally do is we started cutting down the forests, and thereby we are normally utilizing for making shelters and all this actually. So two things have happened as far as this particular industrial revolution is concerned. We started producing more and more carbon dioxide and oxides of nitrogen and other greenhouse gases by burning fossil fuels, more and more by burning more and more fossil fuels actually. The second one is since we are normally our number is increasing, we need more shelters actually, and as a result of this, probably we started cutting down our forests actually. So these two things happened actually, and once you started producing more and more carbon dioxide and other greenhouse gases, and on the other hand, you are normally reducing the green cover, which is supposed to absorb this particular greenhouse gases actually. So then start these two processes, they normally started increasing the concentration of this particular greenhouse gases in the lower atmosphere. Since the Industrial Revolution began in about 1750, carbon dioxide levels have increased nearly by 38% as of 2009, and methane levels have increased by 148%. So that means and two things actually. You started producing more and we started cutting down this particular forest. As a result of this, there is buildup of this particular greenhouse gases as far as the lower atmosphere or troposphere is concerned. And once this particular gases are there, actually, they try to normally, they because of their special property, they try to normally absorb this outgoing infrared radiation, and they try to, they are retaining this particular outgoing infrared radiation, and as a result of this, there is a slow and steady increase in the temperature of the lower atmosphere. So this is what exactly is happening actually as far as this is concerned. So apart from this, some of the extra energy from a warmer atmosphere radiates back down to surface, raising the surface temperature. By increasing the concentration of greenhouse gases, we are making Earth's atmosphere a more efficient greenhouse. So since we are normally increasing this particular greenhouse gases, we are normally making it more efficient greenhouse actually. And the very purpose of greenhouse is to increase the temperature. So here also actually, in the lower atmosphere, the temperatures are normally slowly and steadily, they are normally increasing. So if you normally compare the natural one and today's one, actually, as I said, actually natural one is the processes that are normally done by naturally. That means you don't have any human intervention there actually. But today's programs, if you take actually, because of the anthropogenic activities, because we are normally growing, the population is normally growing, the science and technology is growing actually, and we are normally going for better livelihoods. So all these things actually, probably we are involved in many anthropogenic activities actually, and these anthropogenic activities, they are responsible for generating more and more greenhouse gases. And if you have more and more greenhouse gases, they try to normally absorb more and more energy which is supposed to leave the troposphere, and they try to retain this particular energy in the troposphere, and as a result of this, probably the temperature of the lower atmosphere is normally increasing. So this is what exactly is happening today actually. And as the Earth moved out of ice ages over the past million years, the global temperature rose a total of 4 to 7 degrees Celsius over about 5,000 years. In the past century alone, the temperature has climbed 0.7 degrees Celsius, roughly 10 times faster than the average rate of ice age recovery warming. So because of the presence of this particular greenhouse gases in the lower atmosphere, probably the temperatures are rising slowly and very steadily actually. So this is what exactly is happening, and this is what when this particular process we are normally calling it as global warming or greenhouse effect. So if somebody wants to normally intervene in at some point of time, you are most welcome. If you want to add something, or if you have any doubts, probably you can normally clarify there itself actually. So you are most welcome actually. So this is something probably which I would like to show you actually, as far as the increasing temperature, rise in temperatures. If you take actually, probably we have some 4 models, 5 models actually. All the 5 models show that the temperature is normally rising. So this is maybe I would like to inform you actually that May 20th hit a record high of 470 parts per million of carbon dioxide as measured at this observatory, which has continually measured carbon dioxide in atmosphere since 1958. So we have measurements right from 1958 actually, And if you normally look at probably May 2020, probably we have recorded 417 parts per million. And as a result of this, probably, and as of now today, if you actually, we are normally slowly and steadily going towards 420 ppm mark. 420 ppm carbon dioxide probably we are normally approaching. And this particular, when you normally look at the greenhouse global warming, actually, probably we are normally seeing different molecules. Maybe carbon dioxide is there, methane is there, nitrous oxide is there, and of course, freons are there. Then probably you have SF6 is there. So many things are normally there. But when you normally look into the absorbing, that means global warming potentials, actually, depending upon the global warming potentials, they normally cause this particular global warming. So carbon dioxide is normally considered as the base point, actually. Carbon dioxide has a GWP of 1. So when you normally look into carbon dioxide is 1, and the GWP of other molecules will be normally measured in terms of carbon dioxide. How many times? Maybe methane is 28 times more than carbon dioxide. Nitrous oxide is something like 298. Maybe nitrous, some of your SF6, if you take, probably it normally runs in some thousands, actually. So that's why mostly the GWP stands global warming potential and is an index used to compare the greenhouse effect of greenhouse gases over the single CO2 equivalent scale. As might appear at first sight, GWP index is a simple value that converts the contribution of substance to global warming to that of carbon dioxide. The following table includes 100-year time horizon global warming potentials relative to CO2. So this is maybe given by IPCC 5th assessment report, actually. Carbon dioxide has 1. And with reference to this, probably we measure the global warming potentials of any other molecule. And here, if you take methane, it's 28, nitrous oxide is 298. Maybe SF6, if you take, probably it normally runs in thousands, actually. If you just look into all the values are normally given in the IPC 5th assessment report. Just you can just go through this particular report, you will find almost all the GWPs of this particular molecules which are considered as global greenhouse gases. So I would like to just show you a small video, actually, how this global warming is normally taking place.
You may have heard of global climate change, which is often called global warming. Whether or not people accept that humans are causing global warming...
1 minute, please. Just I will increase the...
You may have heard of global climate change, which is often called global warming. Whether or not people accept that humans are causing global warming, most folks have an opinion about it. But how much do regular people understand the science of climate change? If you were asked to explain how global warming works, could you? Take a moment to try to explain to yourself how virtually all climate scientists think the Earth is warming. What is the physical or chemical mechanism? Don't feel bad. If you're anything like the people we've surveyed in our studies, you probably struggled to come up with an explanation. In fact, in one study, we asked almost 300 adults in the US, and not a single person could accurately explain the mechanism of global warming at a pretty basic level. This is consistent with larger surveys that have shown that people often lack knowledge about climate change. But how can we make informed decisions without understanding the issues we're debating? Allow us to give you a short explanation of how global warming works. First, here is how Earth's temperature works without considering how humans influence it. The Earth absorbs light from the sun, which is mostly visible light. To release that light energy, Earth also emits light. But because the Earth is cooler than the sun, it emits lower energy infrared light. So, Earth's surface essentially transforms most of the visible light it gets from the sun into infrared light. Greenhouse gases in the atmosphere, such as methane and carbon dioxide, let visible light pass through but absorb infrared light, causing the atmosphere to retain heat. This energy can be absorbed and emitted by the atmosphere many times before it eventually returns to outer space. The added time this energy hangs around has helped keep Earth warm enough to support life as we know it. Without this greenhouse effect, caused by these greenhouse gases in the atmosphere, the Earth's average surface temperature would be about 50 degrees Fahrenheit cooler, which is well below the freezing point for ice. So, how have humans changed things? Since the dawn of the industrial age, around the year 1750, atmospheric carbon dioxide has increased by 40%, and methane has almost tripled. These increases cause extra infrared light absorption, meaning an extra greenhouse effect, which has caused Earth to heat above its typical temperature range. In other words, energy that gets to Earth has an even harder time leaving it, causing Earth's average temperature to increase, thus producing global climate change. In case you're wondering about what makes greenhouse gases special, here are 2 sentences of slightly technical information. Greenhouse gases, such as carbon dioxide, absorb infrared light because their molecules can vibrate to produce asymmetric distributions of electric charge, which match the energy levels of various infrared wavelengths. In contrast, non-greenhouse gases, such as oxygen, that is O2, don't absorb infrared light because they have symmetric charge distributions even while vibrating. To wrap up, we'll quickly summarize the mechanism of global climate change. Earth transforms sunlight's visible energy into infrared light, and infrared energy leaves Earth slowly because it's absorbed by greenhouse gases. As people produce more greenhouse gases, energy leaves Earth even more slowly, raising Earth's temperature even more than it has already gone up. That's how global warming happens. This wasn't so hard to understand, right? In these few minutes, you've hopefully become one of the few people who understand the mechanism of global climate change. Please share this video with others so you can help them understand how global warming works too. Thanks for listening.
So just now you had a small, maybe a 5-minute video probably, which will, which you definitely you must have, you have taken the mechanism. In fact, I wanted to show you the mechanism actually. The mechanism is the outgoing, incoming radiation, the troposphere is transparent to the incoming radiation, whereas the gases that are normally present in the troposphere, they normally absorb the outgoing radiation. Actually, this is what exactly is happening as far as global warming is concerned. And as a result of this, probably this absorption of outgoing radiation by the greenhouse gases within this troposphere is responsible for this particular slow and steady increase of this particular temperature, which we normally call as global warming or greenhouse effects. So this is the mechanism through which this is normally happening. So the data from WMO indicate that the temperature of world is getting warmer. So definitely this is one thing actually, as far as all the indicators are there actually, or all the models normally say that the temperature of the world is normally increasing. So this is one thing that is normal, and probably everybody's perception in the group is also the same thing. If I am correct, actually, you will have the same perception. If you normally compare today's temperature with that of something like the temperature of 5 years back, definitely you will find that there is a certain increase. Maybe whatever may be the increase, that there is certain increase as far as the temperature is concerned. According to scientists as NASA, maybe I think the National Aeronautics and Space Administration, Goddard Institute for Space Studies, the average global temperature on Earth has increased by a little more than 1 degree Celsius since 1880. Two-thirds of the warming has occurred since 1975 at a rate roughly 0.15 to 0.20 degrees centigrade per decade. So it is very clear that almost all the models that we are normally using today, actually, they normally point out that the temperature is normally increasing. Temperature is increasing, and the temperature increase is also much high when compared in the last maybe around 40 to 50 degree years. If you take, actually, the rate of increase is much high when compared to the earlier periods, actually. So this is very clear from all the models. Maybe whether you take NASA model or whether you take any other model that we have, maybe around 4 or 5 models are in vogue, actually. And in 2019, the average temperature across global land and ocean surface was 1.71 degrees Fahrenheit, that is 0.95 degrees centigrade, above the 20th century average of 57.0 Fahrenheit or 13.99 degrees centigrade, making the second warmest year on the record. So every count normally, if you normally look at, actually, either you take our perception or you take different models, actually, that the lower atmosphere is slowly and steadily increasing. The temperature of the lower atmosphere is slowly and steadily increasing. So this is the perception, and also these are the records or the statistics normally say. So the global annual temperature has increased at an average rate of 0.07 degrees centigrade per decade since 1880, and over twice that rate since 1981. So again, if you normally look at, actually, in the past 140 years, actually, maybe from 1981 onwards, actually, the rate is much more, or twice, actually, when compared to the earlier rate. The 5 warmest years during 1880 and 219 record have all occurred since 2015. 2015 onwards, probably we have recorded all the 5 warmest, or maybe the 10 warmest years have occurred since 2005. So in recent times, probably we are seeing a higher rate of this particular global warming in recent, maybe I think from 80 onwards, probably. From 1900 to 1980, a new temperature record was set on an average of 13.5 years. So since 1981, it has increased to every 3 years. So earlier it was 13.5 years we were normally measuring. Now we have taken 3 years as an yardstick. It can be said that the industrial activities that contributed to our new modern civilization has raised the atmospheric carbon dioxide emission from about 280 ppm to more than 417 ppm in a span of 150 years. That means if you normally look at the before industrial revolution, probably the carbon dioxide concentration was around 280 ppm. And as I said, actually, in May 2020, probably we have recorded 417 ppm of carbon dioxide. So this is the growth that we have seen, actually, maybe from 1750 onwards to this particular date actually, we have increased the concentration from 280 ppm to 470 ppm. And since we are increasing carbon dioxide, so more and more increasing carbon dioxide in the atmosphere actually, or lower atmosphere, automatically it is normally retaining this particular infrared radiation, and as a result of this probably there is slow and steady increase in the temperature of the troposphere, which we normally term it as something like global warming or greenhouse effect. So this is what exactly is happening if you normally look at the global warming actually. The troposphere is normally transparent to the incoming radiation, but it is normally opaque to the outgoing radiation. And as a result of this, the outgoing radiation is normally retained. And this, once the energy is retained, automatically it increases the temperature. So that is what exactly we are normally calling it as global warming or greenhouse effect. Then what are the negative impacts of this particular global warming? Let us normally see what are the impacts of this particular global warming. And these are some of the, these are not all the things actually, but some important things I have brought to your notice actually. But there are many impacts actually, which we normally call climate change. Climate change is one particular buzzword which we are normally using as far as global warming is concerned actually. So when you normally look at the negative effects of this particular global warming, melting of ice, sea level rise, sea level increase in sea level, and longer wildfire seasons, heat waves are more intense, severe droughts are taking place, changing seasons, food supply disruptions, coral reef disruptions, abrupt climate changes, oceans are warming and acidifying. So you have many things actually, but I try to provide you some information, some very important informations I try to provide you actually. So let us see actually what is let us see what is the evidence of this particular rapid climate change. So climate change is normally taking place, but the evidences normally show, or the evidences that we are normally seeing today normally confirm that it is rapid actually. So you have the global warming is normally taking place as a result of this rapid climate changes are normally occurring. So let us see actually. And this is one particular statement coming from the Intergovernmental Panel on Climate Change, IPCC. So scientific evidence for warming of the climate system is unequivocal. So global warming is taking place. It is true actually, but some scientific groups still normally are arguing that it's not taking place, but it is the scientific the warming is normally, global warming is taking place, and you have scientific evidence actually. There's absolutely, there's no doubt about it actually. And let us see actually some of the evidences that we normally see. Sea level rise. So this is the first thing that we normally see actually as far as sea level rise is normally taking place, because global warming in the sense slow and steady increase of this particular global temperature, and once the global temperature is normally increasing automatically, it has a very bad impact on the icy continents actually. Icy continents, if you take actually Arctic and Antarctic probably, whatever may be the increase in temperature actually, if there is increase in temperature, automatically to that extent actually the solid ice will normally melt. And once this particular solid ice normally converts itself into liquid water actually, then automatically the huge amount of water that is normally coming from this particular melting actually, they have to normally be contained only in this particular ocean basins actually. That's why the sea levels are slowly and steadily rising. Sea levels are rising actually just because the ice is melting, and whatever water that is normally the liquid that is coming from this, actually it has to be normally contained by this particular oceanic basins. So global sea level rose about 17 centimeters in the last century. The rate in which in the last decade, however, is nearly double that of the last century. So again, we have to accept the fact that the sea levels are normally rising. Sea levels are rising actually, and it is normally said that maybe 0.3 to something like 3 millimeters is the rate at which they are normally increasing. Increasing. So that is one thing probably per year I have given. The rate of sea level rise in the satellite era has risen from 0.1 inch per year in the 1990s to about 0.13 inches per year today. So each year, if you take, actually maybe there is certain amount of increase as far as this particular sea level is concerned. And I tried to provide some information regarding this particular India. The IPCC climate change report makes it clear that the world will see greater sea level rise, higher frequency of droughts, floods, and heat waves, and countries like India with a large population dependent on agriculture and fishery would be most affected. So mostly this particular report actually given by IPCC and also our Delhi-based environment think tank, Center for CSE. This is also made it very clear that this particular sea level rise will be disastrous to some of the countries, in which India is also one actually. Some of the countries already we have seen, actually Maldives, Madagascar, Japan, Bangladesh, and of course India is also normally showing this particular signs actually. Maybe if you normally look at the east coast, the Tamil Nadu portion, if you take, there is people have observed some sort of subsidence actually in the Tamil Nadu coast actually. So we have some indications and indicators are already seen actually as far as this particular sea level rise is concerned. And then global temperature rise. So this is what exactly global warming is: slow and steady increase in temperature, and it's one has to accept. But only thing is, actually the average global temperature on Earth has increased by a little more than 1 degree Celsius since 1880. 2/3 of the warming has occurred since 1975 at a rate of roughly 0.5 to 0.20 degrees per decade. This is again a NASA report I have taken. So all the three major global surface temperature reconstructions show that Earth has warmed since 1880. Most of this warming has occurred since 1970s, with the 20 warmest years having occurred since 1981, and with all 10 of the warmest years occurring in the past 12 years. So that's why each and every indication, if you take, actually that the globe is normally the global temperatures are increasing, global temperatures are rising actually, and in recent time the rate of increase has also increased dramatically. And warming of oceans. Once the surface is, once the atmosphere is normally getting warm up, automatically the oceans also normally they absorb more and more energy, and as a result of this, probably you normally see the temperature of this particular oceans are also rising. So the oceans have absorbed much of this increased heat, with the top 700 meters of ocean showing warming of 0.302 degrees of Fahrenheit since 1969. So these are all statistically, these statistics probably we are getting from 2 or 3 models actually. All the models, they normally show that there is certain increase as far as this particular oceans are concerned. The temperature of the oceans is increasing of a little more than 1 degree Fahrenheit on an average over the past century. But the warming is speeding up. The top part of the ocean is warming up about 24% faster than it did a few decades ago, and that rate is likely to increase in the future. So every indication normally says that the oceans are normally getting warmed up. So this is again happening. And again, shrinking of ice sheets. So, as I said, actually, once temperature is increasing, automatically it try to normally reduce the ice quantities actually. And the same thing we have normally seen in Greenland, Antarctic ice sheets, maybe Arctic. All these things probably, if you normally look into, probably we are normally seeing the reduction as far as this particular ice is concerned actually. And declining, or as I said, Arctic sea ice is also normally, both the extent and the thickness of Arctic sea ice has declined rapidly over the last several decades. And again, glacial retreat is also normally reducing actually. And once it normally reduces, here probably you can just think of a sharp decline in with the water from mountain glaciers. Serious problems are inevitable. Nearly 25% of the world population will be normally affected, because if you normally look at actually 25% will be normally affected because of this particular disappearing of the slow glacial retreat is normally responsible for this particular thing actually. Maybe your Himalayas, Alps, and also Andes and Rocky Mountains, all these things, they are normally affected by this particular thing. And extreme events. These extreme events probably in India, probably we have seen even from 2014, we have seen actually Hudhud. In 2007, okay, and 2008 Titli, and 2009 Fani, and 2020 Amphan. These are the cyclones actually, tropical cyclones, which we have seen actually, and we have seen the devastation of this particular Titli, and of course Titli, Hudhud, probably the much devastation has taken place, especially in Andhra Pradesh, Orissa, and all that actually. And as ocean is also normally, because of the more and more carbon dioxide actually in the atmosphere, maybe some of this particular carbon dioxide is normally going into the ocean, and as a result of this probably it is normally acidifying this particular oceans actually. So this is also normally happening. And decreased snow cover, because of the increased temperatures, decreased snow cover is normally seen actually. So all these things, if you normally look into, because of this particular global warming, many things are normally happening, and as a result of this probably, finally you normally see in the form of economic and ecological disasters are normally taking place. But if you normally look into the pandemic, this pandemic didn't solve climate change. Recent disasters are a testimony. So people thought that this lockdown period is normally good for this particular so-called environment and all that, but probably it is only a very short-lived actually. Due to COVID-19 restrictions, the world has enforced lockdowns and social distancing, and initially we thought that it would put a lasting dent on our collective carbon footprint and save the world from warming, but it is not true. Last few years, massive glaciers are tearing loose from Antarctic and Greenland ice sheets, driven by increasing high temperatures at the poles, and in turn accelerating sea level rise and posing enormous threat to the millions of people living in the coastal. So it is only a very short-lived actually as far as this particular pandemic is concerned. And of course, we have noticed devastating wildfires in recent times actually. And one thing I would like to normally mention is Hurricane Sally, which maybe September 2020 probably we have seen actually. It impacted Bahamas, Cuba, US, Gulf Coast actually, and the approximate economic loss was something like 7.3 billion US dollars, maybe most of the time actually. So though there were no deaths actually, there was huge economic loss and also ecological loss actually. And of course, despite these happenings, political leaders want to use climate change for their political gains. The President of United States, Mr. Donald Trump, referred the global warming as a hoax in the past and now claims that it would soon start to get cooler. But the IPCC, Intergovernmental Panel on Climate Change, has established that it is unequivocal that the planet will continue to warm if we continue to emit carbon dioxide into the atmosphere. And at present, even with the small blip of COVID-19 restrictions, we are still emitting billions of tons. So this is what exactly is the thing. And IPCC is a world body actually, which was established by World Meteorological Organization and United Nations Environmental Program in 1988, and it normally advises the policy holders, actually policy makers, and how to normally go about to reduce this particular, mitigate global warming, as well as to go for adaptations. And probably these are the pictures that I have realized in the month of September 19, 2020. This is San Francisco, maybe at 10:25, September 9th, 2020, and again at 10:55 actually, because of wildfires in California, probably we have realized this type of pictures actually as far as United States of America. Then after looking into all these things, probably that it is certain that global warming is taking place. Then what is the way out? Probably how to go about this? Maybe we have two options actually. One is, if you want to address this particular problem, you have only two options. One is at the institute, you have to address this at the institutional level. Maybe the second one is at the individual level. That means institution levels, in the sense, probably we have gone for Kyoto Protocol in 1977 and Paris Agreement in 2015. Of course, unfortunately, this Kyoto Protocol is not even accepted by the United States and some 4 other countries actually. And the Paris Agreement set out a global framework to avoid dangerous climate change by limiting global warming to well below 2 degrees centigrade. And of course, this to some extent people are normally trying to accept this particular Paris Agreement, and India pledged to reduce the emissions intensity of its gross domestic product by 30 to 35% over 2005 levels by 2030. That's why we are normally going for more and more renewable energy. So that is what exactly the Prime Minister of India has said in recent times. And then the second one is actually at the individual actions, limiting the use of fossil fuels and promoting renewable resources, practice and promote mass transportation, use more vegetarian diet. That means non-vegetarian diet will normally produce 40% more emissions when compared to vegetarian diet, and try to limit the flying habits actually. So if you are normally a frequent if you are taking a frequent flight, probably then you will be normally producing more gases. Then promote local foods and fabrics. Less population will be you will be reducing. That means each one contributes nearly 5 tons of carbon dioxide per year. So that's why maybe if you normally reduce the population, automatically you can normally reduce the emissions. Practice and promote afforestation programs, organize more awareness programs, and promote green technology. So at the individual level, you may have many, but some of the things which we can easily practice actually is as teachers, you can normally promote more and more awareness programs. You can use your people, actually student force, and you can normally go for this particular awareness programs and try to normally reduce this particular environmental issues, problems with environmental issues. So maybe now the time is almost over actually. So now if you have any queries, probably I'll try to answer for a minute or two before I normally wind up this particular presentation. And if you have any,
thank you, sir.
I'll answer.
Sir, thank you, sir, for a nice presentation. Sir, I have a query. Means how say in last slide you have shown that local promoting local foods and fabrics can say
Yeah.
help in. Can you explain that one, sir?
So local foods in the sense actually maybe now we have actually the local weavers. Probably they are normally local foods and local fabrics in the sense locally made fabrics in the sense weaving. So try to normally promote weaving. That's what exactly that. If you are not using any machine, actually you are not producing any gases. That's what exactly. So most of the time, even the same thing actually, local foods will normally, you are not using any machinery actually, automatically you will be normally reducing the gases. That's what exactly local foods and local fabrics. But it may not be possible, but it is one way actually, an individual action. Probably you can always promote local foods, and if not fabrics actually, local foods you can always promote, definitely.
Thank you, sir.
Hello, sir. Sir, this is Dr. Iswar Boitham, sir.
Okay.
I am from Environmental Science Department. Sir, I have one question, sir.
Okay.
Uh, Sir, as you have already told, the carbon dioxide is the major greenhouse gas which causes global warming.
Okay.
So basically, carbon dioxide is very essential also in maintaining the global temperature, and
Yeah.
it can easily be removed. Yes, sir. It can be easily be removed by carbon sequestration processes because you can increase the forest cover and other things.
Okay.
My question is, sir, there are other gases like sulfur hexafluoride, carbon CFCs, and other greenhouse gases which has higher global warming potential.
Yes.
Why they have around some has 6,000 times more global warming capacity compared to that of the carbon dioxide.
Yes.
So why we give more importance to carbon dioxide when we discuss about the global warming only?
Okay. Very good question actually. Probably if you normally look into, as I said, actually today's energy requirements are normally met by the fossil fuels. Actually, most of our energy requirements are maybe around 70 to 75% of our requirements are normally met by the fossil fuels. That means you are normally using coal, oil, and natural gas for energy generation. And
Yes.
it is also said actually that because we want to have better life, actually we want to normally go for better economy. That's why we are normally increasing our industrial bases actually, and as a result of this, what we are trying to do is actually we are trying to generate more and more energy from this particular conventional energy resources. And once we are normally using more and more conventional energy resources like coal, oil, and natural gas, you are bound to produce a lot of copious amounts of this particular carbon dioxide as well as oxides of nitrogen actually. And if you compare the volumes of other greenhouse gases actually, the volume of carbon dioxide that is coming into this particular troposphere is much higher actually. That's why all the time we normally blame carbon dioxide, though there are other gases whose global warming potential is much higher actually. Their volume is very less. So that's why probably we always consider carbon dioxide as a culprit rather than other gases.
Okay, sir. Thank you, sir. Sir, I have another question, sir.
Okay.
There are many reports where the people have shown okay, there may be certain link between the climate change that is happening with that of the pandemic, COVID pandemic, so any sort of that kind of pandemics that are happening.
Yes.
So, do you think there is any link between the climate changes and the incidences of pandemic?
No,
Would you say that?
incidences of pandemic actually, as far as, in fact, people thought actually, or almost all the climatologists and environmental scientists, they thought that this particular pandemic will normally help the environment in a very big way actually. But unfortunately, it normally happened for a very short period, and now again the concentrations are normally increasing actually once the lockdowns are normally once we are going for, we are moving towards positive side, or rather once we are opening all these particular things actually, then again we are going for more and more generation of energy gases actually. But the second thing is actually this pandemic is also normally has some impact as far as the waters are concerned, especially waterfront. If you take waters are more rather polluted actually when compared to earlier days actually. The
Okay.
most of the time actually, because of this particular usage of different types of materials, probably they have again finally they have reached this particular hydrosphere, and as a result of this the quality of this particular waters have gone down. So that is
Okay.
one thing which we have observed.
Sir, sir, another question, sir, I have. Global warming, sir, will it have equal impact on the third world country as well as the developed country? Like you see, if you look back, in last few years, India has suffered from number of natural disasters, and
No,
some of the reports say, some
but
of the reports says,
the same thing, if you normally look at the Atlantic coast also, they have also suffered actually. But the thing is, um, in a in the third world countries, the resources are limited. So you have limited resources actually. That's why, yeah, even if there is damage, probably the damage will be very much apparent actually. Whereas in the case of developed countries actually, because they have more resources, even if there is some damage immediately, it will be normally covered immediately actually, because of the because of their availability of more resources and all that. But if you normally look into, probably this is a global phenomena that is normally taking place. That's why you normally find a similar type of impact, but the impact will be visible in the case of third world countries and underdeveloped countries, whereas it is not so much of it is not seen so much as far as this particular developed countries are concerned.
okay. Thank you, sir. Thank you very much, sir. Nice.
Sir,
Yes.
we cannot ask some more questions. So directly we are moving at the end of the discussion that is proposing vote of thanks.
Excuse me.
So if
Excuse me. Can you repeat the question actually?
so this is not my personal query. We are coming to an end. This is vote of thanks proposed by me, that is Dr. Deepika, Department of Law, Sambalpur University.
Okay.
So actually coming to an end, because next we are getting late.
Okay, the net is not good actually. It seems the connection is not good actually. Okay, I thank you for your patient hearing, and tomorrow we'll be meeting once again, and I'll be normally discussing this municipal solid waste and its smart management of municipal solid waste at between 3 and 4:30.
So, Professor Director of Professor Kumar Sahu, and other intellectuals, I, Dr.